Good morning, children. Welcome to CEI. This is Dr. Sekhar Chandra. I'm the teacher of chemistry. Today I'll teach another new topic, that is hydrogen gas. It will be preparation of hydrogen, properties of hydrogen, and uses of hydrogen. Okay, children, let's start with the preparation of hydrogen gas. Now, preparation of hydrogen gas. How you prepare hydrogen gas? There are several ways. Just I will mention important few methods how to prepare with few examples. Now first, how you prepare hydrogen from water. So let's discuss with the preparation of hydrogen from water. From water. Which type of water? Water at room temperature. Water at room temperature. Now, some metals, they are alkali metals like sodium, potassium, lithium, even alkaline earth, calcium, they react with water at room temperature to produce hydrogen gas with the formation of the respective alkalis. Like sodium combines or reacts with the water to form sodium hydroxide with the evolution of hydrogen gas. Similarly, calcium, which is not alkali metal but alkaline earth, it will also react with the water at room temperature to form alkali, that is calcium hydroxide and hydrogen gas. One example I am writing, that is potassium. 2K plus water will get 2K OH plus hydrogen gas. Okay. Similarly, twice Na plus water, twice NaOH. Calcium, Ca plus water will get CaOH whole twice plus hydrogen gas. Now here we get hydrogen gas at room temperature. Okay. Similarly, boiling water. Now boiling water, there are few metals are there which they combine or they react with boiling water to form hydrogen gas with respective oxide like zinc, lead, magnesium, etc. They combine with water at boiling condition, that is Zn plus water will get the ZnO plus hydrogen gas. They react with the water condition is the boiling water, like lead, like magnesium, like aluminium, they also react with the formation of hydrogen gas. With steam, what reaction? When steam is passed over red hot iron, then iron becomes oxidized to Fe3O4, ferrous oxide with the evolution of hydrogen gas. What is the reaction? 3Fe plus 4H2O, 3Fe plus 4H2O, reversible reaction, Fe3O4 plus 4 hydrogen. This is steam. Here it will be the steam. Now, let me conclude. Now one thing, this reaction known as Lenz process, LANES, Lenz process. This process can be used. This process can be applied or can be used to manufacture hydrogen gas and known as Lenz process. So let me conclude. Water. There are three conditions. Hydrogen can be prepared from water in three conditions. First of all, alkali metal, room temperature, some metals, boiling water, and iron from steam. Then in these three conditions we can get from water hydrogen gas. Next part, from acid. Now we know that there are three kinds of acids are there: hydrochloric acid, sulfuric acid, and nitric acid. Now, metals which are above hydrogen in the electrochemical series, they combine with dilute acids to form hydrogen, to evolve hydrogen gas with the formation of the respective salts. Like if dilute HCl is added or dilute HCl is used, then we get metal chlorides and hydrogen gas. If we take sulfuric acid, dilute sulfuric acid, then we get respective sulfates and hydrogen gas. And if you take nitric acid, dilute nitric acid, then we will get metal nitrates and hydrogen gas. The important point, all acids should be dilute because concentrated cannot be used. Why? Concentrated HCl is a reducing agent, not acid. We get hydrogen from acids only. Concentrated sulfuric acid is not acid, it's an oxidizing agent, and nitric acid also oxidizing agent. So dilute acids are to be required. One example, zinc plus HCl, we get zinc chloride plus hydrogen gas, then Fe plus H2SO4, FeSO4 plus hydrogen gas, magnesium plus HNO3, we get magnesium nitrate plus hydrogen gas. One thing that magnesium and manganese, in case of nitric acid, only magnesium and manganese can be used. No other metals can be used for the preparation of hydrogen. But in other cases, metals which are above hydrogen in the electrochemical series can be used. Sulfuric acid, in case of sulfuric acid, one thing you have to remember, those form the insoluble sulfates. Insoluble sulfates, those metals cannot be used for the preparation of hydrogen because they protect the metals from the sulfuric acid. So those type of metals like lead, calcium, strontium, barium, they cannot be used for the preparation of hydrogen or from sulfuric acid, though they are present above hydrogen in the electrochemical series. Okay, then from water, from acid. Now next is from alkali. From alkali, few metals like zinc, few metals like zinc, aluminium, lead, tin, antimony, they also produce hydrogen gas from the alkalis. But the important metals are, according to your syllabus, will be the zinc and aluminium. So only we will consider zinc and aluminium. Now zinc reacts with sodium hydroxide or potassium hydroxide, they produce hydrogen with the formation of the salt, that is sodium or potassium zincate. In case of aluminium, they form aluminate, sodium aluminate or potassium aluminate, and with the evolution of hydrogen gas. Now let me write the reactions in these two cases because this is very important. Twice NOH, we get Na2ZnO2 plus hydrogen gas, aluminium twice Al plus twice NOH plus twice water, we get twice NaLO2 plus 3 hydrogen. So we get hydrogen gas from alkali. Important is zinc and aluminium, though there are so many metals are there like lead, like tin, like AS, arsenic, they also react with the alkalis to form respective salts and hydrogen, but important according to syllabus will be the zinc and aluminium. So zinc and aluminium produce hydrogen gas with the formation of the respective salt. Next part, then we can say that first we discuss about the water from which we get hydrogen gas. From acids, dilute acids, we get hydrogen gas. From alkali, we get hydrogen gas. Next part will be next from metal hydride. Metal hydride like sodium hydride NaH, potassium hydride KH, calcium hydride H2. They on hydrolysis they produce NOH, alkali respective alkali plus hydrogen gas. Similarly, potassium hydride also on hydrolysis they produce potassium hydroxide and hydrogen gas. calcium hydride, they also on hydrolysis produces calcium hydroxide with the evolution of hydrogen gas. Next, from ammonia. From ammonia also we get hydrogen gas. How will we get hydrogen gas from ammonia? When ammonia gas is passed over heated sodium or potassium metal, then we will get a respective sodamide or potassium amide with the evolution of hydrogen gas. Examples or balanced equation will be the Na sodium plus ammonia. We get NaNH2 plus hydrogen gas. Similarly, K plus NH3, KNH2 plus hydrogen gas. Twice Na, twice this, twice there's 2 and hydrogen gas. So potassium and sodium alkali metal combines with the ammonia gas to form sodamide or sodium amide, potassium amide, potassium amide with the evolution of hydrogen gas. So there are gel method of preparation of hydrogen gas. No more gel method of preparation. Then we will discuss about the manufacture and laboratory method of preparation of hydrogen gas. So next is manufacture of hydrogen gas. Next part is manufacture of hydrogen gas. Manufacture of hydrogen gas. This is known as Bosch process. By which? Bosch process. By this method, we can prepare hydrogen gas, or we can manufacture, or we can prepare industrially hydrogen gas in this method, Bosch process. What is that? Now, there are 3 steps on this Bosch process. First step will be when steam is passed over white of coke, then we get a gas mixture which is known as water gas, which is a mixture of carbon monoxide and hydrogen. This carbon monoxide and hydrogen gas mixed with the steam under high pressure and in the presence of catalysts like CF2O3 and Al2O3 at the temperature of 500 degrees Celsius, they passed. Then they will get the mixture of carbon dioxide and hydrogen gas. And this mixture of carbon dioxide and hydrogen gas will pass through water under high pressure. The carbon dioxide dissolves in water to form carbonic acid, and hydrogen gas is released. Instead of water, we can also use second line to reduce the cost price of this manufacturing method. We get a hydrogen gas in this method. So there are 3 reactions will be there. C plus steam, we get carbon monoxide plus hydrogen. This is known as water gas. Second step will be water gas plus steam mixed, we will get the carbon dioxide plus hydrogen. This will be the catalyst Al2O3 or Cr2O3 and the temperature of 500 degrees Celsius, and then this mixture will pass through water or under calcium hydroxide, then carbon dioxide will be absorbed and hydrogen gas will be bubbled through. Okay, so let me conclude. The 3 steps will be there. First step is the water gas preparation. Second is the water gas converted into a mixture of carbon dioxide and hydrogen, and then carbon dioxide will be removed either by passing through lime water or second line or under pressure through water. In this way, carbon dioxide can be removed, hydrogen gas will be released. So this is the method for manufacturing of hydrogen gas. And another method is very important, that is electrolysis of water is very cheap, so it is more popular than the Bosch process, that is electrolysis of water. Electrolysis of water. What is that? When electricity is passed through water, acidified water means water acidified with sulfuric acid, then water dissociates into H plus ion and OH ion. H plus ion will be attracted by the cathode, where it accepts electrons and gets deposited over it and released as bubbles of hydrogen gas. On the contrary, hydroxyl ion will be attracted by the anode and then releases this electron, and then OH free radical will be obtained. This 4 OH will combine together to form water molecule and 1 molecule of oxygen and is released. So in this way, we can prepare hydrogen and oxygen together. So this is a very popular and very cheap method. So it is more useful in this world. So by the method of electrolysis, we get hydrogen and oxygen simultaneously. This is all about the manufacturing or manufacture of hydrogen gas. And finally, preparation in the laboratory preparation of hydrogen gas. Laboratory preparation of hydrogen gas. Now, in the laboratory, hydrogen gas is prepared by the action of dilute HCl on zinc granules. Now, zinc granules, because impure zinc is called zinc granules, because impure zinc is more reactive than the pure zinc in this case. So impure zinc we use for the preparation of hydrogen gas in the laboratory. So in the laboratory, zinc plus the 2HCl dilute hydrochloric acid to form zinc chloride hydrogen gas. This hydrogen gas is then is collected by the downward displacement of water. And very important point, this hydrogen gas is very dangerous, because if it is not properly taken care, then it will explode, because you know the mixture of hydrogen and oxygen is explosive mixture. So when we will collect the hydrogen gas, very carefully we have to collect by the downward displacement of water. Okay, today is no more because time will not permit. Thank you. The next day we will discuss about the questions regarding the preparation of hydrogen gas. Okay, now let me complete today. If you like this video, please like it, share it and subscribe. Thank you.